Hello and welcome to another session of Streaming School. So now we're going into the first of our two maths lessons today, and this is going to be the live lesson with Mr. Sam Winch. So a very good morning to you, Sam. How are you today, buddy?
Good morning, guys. Yeah, it's Friday today, I think. I'm struggling to work out what days we're on, but it's Friday, yes, I'm really good. And sun is shining as always. So long may this continue, because I think Streaming School is bringing out the sunshine.
Yeah, it's like nature's way of teasing us. The longer that you're not actually in space. I think you've got the camera on your visualizer for a second, Sam.
Yeah, okay.
I kept thinking it was your presentation. I was like, no, we're definitely not doing that. Is that where you want it to be for the start?
No, I want it to be on my face, and you've got it on the visualizer. I can see that. So let's go stop presenting, and I'll come back and see if we can try again. See my face now?
No, fantastic. Well, obviously, we do want to see your face. I think it's still choosing to go through your visualizer, buddy, but it doesn't really matter because obviously people are waiting for maths this morning. So I'll just get out of the way.
Yeah, we'll go straight to the
present, and we'll go from there. So yeah, thanks very much for all your efforts and everything so far. Really, really keen to get more of your knowledge imparted on as many people as possible. So the floor is now yours, as they say.
Brilliant. And what I'll do is I'll just load up PowerPoint, and just to double check, Leon, can you now see our recap?
Yes.
As it's loaded.
They're perfect, yeah.
Brilliant. Okay, guys, I'll get started. And meanwhile, before we go on to that recap, actually, I'm just going to load up my trusty visualizer. As you know, it's worked pretty well so far. So we want to make sure we have that in the background, because today I'm going to do a couple of examples of topics of what we're talking about today. So just to recap, you should see on your screen now the recap of last week. It's on Wednesday's session. So on Wednesday's session here, we're talking about fractions. So we've got multiplying, division, addition, and subtraction. So I'm going to breeze through the recap. There's 6 things we picked up on Wednesday. There's going to be 2 more that we speak about today. So I'll quickly go through the recap. That is, when subtracting and adding fractions, make sure you find the denominator the same. And then once you've found the denominator to be the same, obviously, you do the same thing to the numerator, and then you can just subtract the top numbers. Of course, if the denominators are the same, you don't need to change anything. So for this first example, we've got 20 as the denominator, 15 minus 8 is 7, so the fraction there will be 7 over 20. Same thing for addition, of course, just add. Multiplying, we just multiply the numerators and denominators, and division was KFC. Keep the first fraction, flip the second fraction, and change the question from division to multiply. Brilliant. Increase, decrease, two ways of doing it. You could find a fraction first. You could, if you want to increase 64 by 3/8, find 3/8 of 64 and then increase it by that number. Or we could change the fraction from 3/8 to 11/8. So add the numerator to the denominator to give us a new numerator. And then we find 11/8 of 64. So that's 2 ways of doing increase, whichever way you find best. Fractional indices was 2/3 of, here we've got 2/3 of 27, so raise 27 to the power of 2 over 3. So we're going to find the cube root of 27, which gives us 3, and then multiply 3 by itself, so 3 squared, which gives us 9. That's fractional indices. Of course, remember, if it's a negative indice, it's just going to be over its reciprocal. So if that was 27 to the power of minus 2/3, it would be 1 over 9. Brilliant. Converting fractions. We've got convert 17 over 40 to a percentage. 2 ways you can do it. You could divide, if you had a calculator, if it was on the calculator paper, you divide numerator by denominator to give us 0.425. So as a decimal, and then of course to make it a percentage, we multiply it by 100. The alternative option would be to work out how many times does 40 go into 100. You might know that that's exactly 2.5 times. So therefore, I'm going to times 17 by 2.5, or 2.5, and that gives me 42.5%. Equivalent and simplifying fractions. Here we've got 7/8 equals 35 over something. What is the something? Well, we know it's 40 because 7 times 5 is 35, or in reverse, 35 divided by 7 is 5. So therefore, we're going to multiply 8 by 5 to give us 40. And then final question here. We've got write 5 3/5 as a top-heavy fraction, or instead of top-heavy fraction, improper fraction. And of course, it is 28 over 5. The way we work that out is we multiply the whole number by the denominator, and that gives us 25, and then you add that to the numerator. Brilliant. So we're going to move on today to finish off with recurring and surds. These are recurring fractions, and surds will be on the high paper. So we're going to give you a quick 5-minute recap as to what they are, a quick introduction actually, a couple of examples, and then we're going to finish the last 10 minutes with inequalities. Okay, and inequalities can really range from grade 3 on the foundation paper right up to grade 7 and possibly grade 8 on the high paper. Okay, so another busy day today. Express the recurring decimal 0.39 as a fraction. Now we know if there's a recurring point there and a recurring point there, we know that we're working between 3 and 9. Okay, so we're working in the tenths column and the hundredths column. So to put it over a fraction, bearing in mind we can't have a decimal as a fraction. So to put it over a fraction, what we do is we find out what x is, and x equals 0.39 reoccurring. So if we multiplied it by 100, we'd get 39.39, 3939 reoccurring, etc. So then if we took away 1x from 100, which gives us 99x, actually 0.39 take away from 39.39 would give us 39 exactly. So 39 over 99 would be the answer to question 1. Okay. If we were expressing the recurring decimal for this one, the difference would be we've got the hundredths column and the thousandths column. So instead of multiplying it by 100x, we've got 1000x this time. We're going to do 1000x, which equals 213.13, and we need to take away something to make it a whole number. Okay, so this time I've decided to multiply this by 10 to give us 2.13. And if we subtract that, that'll give us a nice whole number of 211. So let me give you a couple of examples. I just want to check that that's my visualizer. You can see my visualizer now, I'm hoping.
Yep, coming through nice and clear, buddy.
Brilliant, cheers, Leon. So we're going to use this first example, which is converting 0.451, 51, etc. into a whole number. So the first thing I would like to do is, let's multiply that by 1,000, because we're looking at the 1,000. That's where the number stops, if you like, or recurs the same. So it's the 5 and the 1. Well, that should be there. So the 5 and the 1 are what we're going to be working with. So I'm going to multiply it, because it's the 1,000th column, we're going to multiply it by 1,000, which gives us 451.51. And then I'm going to subtract 1,000 by 10x. 451, well, we know 10x, if we multiplied that by 10, that would just give us 4.51, wouldn't it? So altogether, the answer to this question, 451.51 subtract 4.51, would give us 447.00, or 447 exactly. So if that take away that's 447, and 1,000 take away 10 is 990, well, that is now our new fraction. So when we're recurring fractions, you've got to turn it into a whole number. And whatever you do here, you repeat the same here, then that will give you your denominator. So we've got my denominators here and my numerator there. Okay, if that makes sense. Let's have a go at this one. It might give you another chance. So we've got 0.512 as a fraction. Give your answer in its simplest form. Okay, so again, we're going to work with, I'm going to times it by 1,000, because here we're working in our thousandths column. Tenths, hundredths, thousands. So 1,000x, that's 100. 1,000x, which gives us 512.12. And I'm going to subtract it by 10x. So that would be 5.12. Of course, now that gives me 507. I've subtracted 10x from 1,000x, which gives me 990x. So we could say x equals 507 over 990. And we want that in its simplest form, so then you could subtract it down as well. Okay? Find the common factor, of course, and then go from there. So the next one would be a different topic. We're going to move back to the PowerPoint, and we're going to go on to surds. So that was a quick fly through of recurring fractions. Now we're going to move on to surds. Now, surds would they would only come up on the higher paper first of all, and if they were asking you to simplify, that would be on the non-calculator paper. If they were asking you to solve a question, then that would be on a calculator paper. But here's the first example of really what a surd is. So a surd is an irrational number. So we know that the square root of 4 is 2. We know that the square root of 9 is 3. They're nice whole numbers. However, the square root of 7 or the square root of 5, for example, would give us a decimal, would give us an irrational number. So that's what a surd is. And what we want to do is look at here how to simplify surds. So this is for a non-calculator paper. And all we're looking at doing actually is just, as it says here, multiply out the sum. So we've got the square root of 3 and we've got the square root of 7. Well, altogether, that is just the square root of 21. So on a non-calculator paper, they just want you to simply simplify the question, and you've got the square root of 21. Again, here, slightly different perhaps, because you've got 24 divided by 6, which we know is 4. And then, can we simplify that out? Yes, we can. Well, the square root of 4 we know is 2. Okay, and then an extension here, you've got the square root of 3 to the power of 2 and the square root of 5 power of 3. So what we're going to do first of all, we're going to multiply the power numbers, and then we're going to multiply the root numbers, which gives us 15. Okay, so that will be simplified down. Okay, so that's surds, that's simplifying surds. Next lesson, next week on Monday, we're going to go into how to answer surd questions on a calculator paper. But what I want to do is to move on to today's topic, which is inequalities. So as you can see, inequalities covers 4 different things. These are the 4 things we're going to be looking at today. Inequalities on a number line, and inequalities on a number line would just be on the foundation paper. Solving linear equalities, and again, that would be on the high paper. The other thing that we're going to try and cover today is solving linear inequalities where you've got 2 inequality symbols, and that could cross over both the foundation and high paper. That would just fit in here nicely. Okay, so let's first of all go through what an inequality is. We're going to start off with the basics of inequalities. We're looking at a grade 3 here, and it's recognizing these symbols. So we know that we've got greater than, and you might remember your teachers talking about the crocodile eats the bigger number, or something like that, or you always point to the smaller number, something along those lines, and you've got greater than, less than, and of course if it's got a line underneath, that just means equal to. So greater than or equal to, less than, equal to. And in terms of a number line, you've got a clear circle and you've got a closed circle. So a coloured in circle and one that's white in the middle, or however you want to describe it. That would then allow us to recognise when it's between a number or where it's between and or equal to the number. Okay, so we're going to see on the screen now, you can see an example of how to represent the number x, which is greater than -1. So we go to -1, but we know x is greater. We don't know what it is, but we know it's greater. So we're going to do a nice clear circle, and we're going to move up and draw a line up from -1. The next example, we've got x is less than or equal to on the number line of 3. So we go to 3, and because it's possibly equal to, it might be the same as 3, we don't know. So therefore we colour it in, and then we draw a line down because we know it's pointing to a smaller number. So I believe, here's one I made earlier. I've got a couple of examples for you here on my timeline. And what we're going to do first of all is look at the first one, which is here, x is less than 4. So x is smaller than 4. So therefore, I'm going to go to 4, my number 4 here. I'm going to do an open circle because we know it's not equal to, and we know it's less than 4. And we're going to draw a line all the way to the end. Let's see if I can keep my paper still. Sorry, not the straightest line. I should use a ruler. There you go. The next number we've got x is greater than 2 or equal to 2. If it's possibly equal to 2, we're going to go to 2. And we're going to colour in our inequality symbol. And we know that x is greater than or equal to. So this time we're going to go in that direction. And then the final one here, we've got question 3, which is x is smaller or equal to -3. So if we go to -3, I'm going to colour in our -3. And we know, of course, that x is smaller or less than -3. So which way does less go? Is it left or right? Of course, we know that the less is to our left. Okay. Okay, so that's inequalities on a number line. I'm going to use these questions down here in a little while when we talk about solving, which is what we move on to now, which is good. Okay, so can you solve this question? 2x plus 3 equals 11. Well, we know that x must be 4 because we subtract 3 from the equal sign. So that will give us 2x equals 8. And then we obviously can divide 8 by 2x to give us what 1x is. Now, if that's how we solve an algebraic linear equation, then of course, inequality equations is the exact same. We've just got an inequality symbol there. So it's x is less than 4. Okay, so that would be what how to solve an inequality. So if I now flick back to my screen and we have a go at these two here at the bottom of my screen, we've got -2. In fact, this question here is relating to the numbers between -2 and 3. Okay, so before we move on to solving, first we want to solve what numbers occur in this inequality equation. So we know that the number x is definitely greater or equal to -2. So -2 is an option, of course, -1, 0. And we know that x is less than 3. So it could be 1, it could be 2, but of course it can't be 3 because it's not equal to 3. So there are the numbers that are between -2 or equal to -2 and 3. So again, for this one, x is greater than 1, so it could be 2. It's less or equal to 5. Okay, so it could be 2, it could be 3, it could be 4. Because it's equal to 5, it could, of course, be 5. Okay, let me flick back to my screen. So solving inequalities. So we've just spoke about that. I'm going to give you a couple of examples here of how to do inequalities. Very similar to algebraic equations, linear equations. So you've got 3x plus 2, which is less than 5. So all we're going to do is subtract that from the answer to give us 3. Of course, 3x divided by 3 would give us just x equals 1. Add that to 30, which gives us, add 4 to 26, which gives us 30. 30 divided by 5, which gives us 6. And the inequality symbol stays the same. So it's x is greater or equal to 6. And then we'll do one more because I'm well aware of time. 35, subtract 35 from 7, subtract 7 from 35, sorry, gives us 28. 28 divided by 4 would give us 7. So x greater than 7. And we'll do one more actually. Here you're going to add 5 to 7 to give us 12. 12 divided by 2 is 6. And then there's your answer. Okay, so let's see if we can finish off with a double inequality. Yes, I think we will actually. So I've got an example here. So on your screen, we've got 5 is less than 2x minus 1, which is less than 13. So we're trying to find out what's between, what x is between, sorry. So we're trying to find out what's on the outside of these two numbers. Now here you've got to break it down by adding 1 to each side. So here you'd have 2x is less than 14. I'm going to add 1 to this side. So it's 6 is less than 2x. And then of course, then divide both your sides. So 3 is less than x and x is less than 7. Okay, I'll finish with one example for you on the trusty visualizer. We've got 2 examples here that you can try. So we're going to start off by saying that we're going to subtract 2 from both sides to give us 21. And you've got 6. Then of course we can divide 6 by 3 to give us 2. and we can divide 21 by 3 to give us a 7, and that will be your answer. Try this one down here. We've got subtract 3 from -8, that's from -5 to give us -8. Subtract 3 from 19 to give us 16. And we divide both sides by 4 to give us -2 and 4. And then the symbols, inequality symbols, stay the same. But Leon, if you can put me back on the screen, please.
Of course, buddy.
So that was inequalities. We started with recurring fractions.
Sorry, Sam,
and
it's still your visualizer, buddy. I think it's the same
Oh,
issue we had
sorry.
right at the beginning,
Apologies.
where you've got your visualizer on and we're seeing your wonderful handwriting rather than your wonderful face.
Okay, I'm wondering why that's happened today. Can't see my face now. I don't know why that is. Okay,
it's not Friday the 16th.
For today, I did talk over. There we go. Anyways, that was recurring fractions, and we had surds. Then we did inequalities. But next week, you'll see my pretty face, and we'll be doing some more inequalities on the high paper with shading regions on quadrant graphs. So I hope you enjoyed today's lesson, and we'll see you on Monday.
Brilliant. Thank you very much, buddy. I really, really appreciate it. It's probably just a setting on the camera. Do you use photo booth for the visualizer?
No, I don't. It just loads up automatically via the camera. I've never had a problem with it before, so I don't know why it's doing.
Friday Gremlins. Your computer wants a day off as well, buddy. You've been on with us every single day, and your computer wants a break as well. Thank you so much. Really, really useful. Obviously, everything is available on Facebook, YouTube, and Twitch. Please do share to help other people, and we will be here every single day of the lockdown. And we've got some more lessons coming up shortly. Niche.
Yeah. So I do have the maths optional task about to come up right now. So it is a worksheet. It has 19 questions, so it's not that long. When it loads, and hopefully it won't be too difficult after Sam's great lesson. Please have a go. I will put the links to this up on YouTube and on Facebook as well. And next we have science. We have biology lesson.
Wonderful. Thank you so much, Nish. And for anyone who is interested, remember you can watch all the live lessons as well that are going on between all the different things in the different places. And we have the rest of the previous lessons available as well. So just go back through if there's anything you want to catch up on some of the maths and follow Sam on different days. If you look on the website, you'll find the timetable and you can follow back through different days and see when he would have done the prior lesson to that. Hope that's of use. And Nish, I will see you in a short while, and everyone else, I'll see you then too.